Okay, for this next problem, it asks us to find these key features, and since we see the word directrix, we automatically know that we're dealing with a parabola here. Seeing the x squared without a y being squared, that's another clue to us. So I'm thinking to myself, I want to have this in the form x minus h quantity squared equals 4p times y minus k, which means I need all the x terms on the left and everything else moved to the right hand side. So here we go. Left side, x squared minus 8x, leave a blank to complete the square, equals negative 2y minus 4. We will cut the negative 8 in half to a negative 16 and square that in half to a negative 4 and square that to a positive 16. Adding 16 to the left means we need to add 16 to the right hand side of the equation also. Completing the square, we now have x minus 4 quantity squared equals negative 2y plus 12. And all we need to do now is factor on the right hand side. So we have x minus 4 quantity squared equals negative 2 times y minus 6. Okay, we have our parabola. We see that x is squared. That tells us it opens either up or down. And since we have a negative leading coefficient here in front of the y term, that tells us this is going to open downward. So sketch-wise, opening downward, vertex or focus inside. Here's my directrix up there. That's the orientation. And we know that the vertex is going to be located at 4, 6, which is what I'm about to plot here up there in the second quadrant. Okay, next set of clues. This negative 2 needs to be examined. 4p is equal to negative 2. That means p is equal to negative 1/2. And from my little sketch, I'm going to be moving down a half and up a half to get to the focus and the directrix. The focus down a half right there will be located at 4, 5.5, which is 11 halves, and the directrix will be up a half a unit, and so that will be the line y equals 6.5, also known as y equals 13 halves. Now, the negative 2 in that 4p position tells us that the lattice rectum will be of length 2. We take the absolute value of that, and so through the focus we go 1 unit to the left and 1 unit to the right. That will add up to 2 for the length of the lattice rectum. And now we can draw in our curve and know that we've got the proper curvature there up near the vertex. Well, this problem asked for one more thing. It wanted to know what are the x-intercepts. Now, we find the x-intercepts by setting y equal to 0. We can either do that in the original problem here, or we can do it in the completed square form, which is what I'm going to do. So let me rewrite our equation down below here. X minus 4 quantity squared equals negative 2 times, and instead of y minus 6, I'm going to substitute in y equals 0 so that we can identify these x-intercepts. We now have x minus 4 quantity squared equals negative 2 times negative 6, which is 12. And we can solve this equation for x by square rooting each side of the equation. This will give us x minus 4 is equal to plus or minus 2 root 3, and x will then be 4 plus or minus 2 root 3. Interpreting this, our x-intercepts will be 4 plus or minus 2 root 3, comma 0.